from Genpact.
Thank you. Good morning. Thank you for joining us this morning. I was in the car driving out to this venue this morning, and I read on my iPhone that neural nets have painted a Picasso that has never, ever been seen. And if you think about art and AI, last year, art sold at 40 times the price it was estimated by Christie's at the time. From art to astronomy, you think about astronomy, we discovered two entirely new planets this year on the back of artificial intelligence. And you look at medicine, where AI is now outperforming humans as it relates to detecting medical symptoms, in this case, pre-cervical cancer. We know that it's ahead of humans today. So the benefits of artificial intelligence in the world that we live in and relate to and together populate is very clear. And yet, I wouldn't say the same for enterprises. In enterprises, the opportunity for AI and applications of AI is very large, but it hasn't seen the adoption and the implementation that matches the potential that it has. And the reasons for that are fairly obvious, and we talked through many of them. We clearly think bias and digital ethics is a large component we need to solve for. We believe explainability is an important component of delivering AI in the enterprise. But by and large, the number one issue we find in the enterprise is the time it takes to get an AI application off the ground. The escape velocity, the critical mass that is required just takes too long. And part of the reason is we start with horizontal, scalable, commodity AI engines. Then we spend a lot of time applying, tuning, contextualizing, deploying, and that total time ends up being larger than most companies, most corporations today have seen the appetite for. Now, this issue is a big issue because for corporations, there's significant disruption that's upcoming, and we know this. Since 2000, 50% of Fortune 500 companies no longer exist, and that's the size of disruption we're starting to see. Since 1980, 80% of S&P 500 public companies do not exist. It's actually estimated that in the next 5 years, another 17% will cease to exist. So you can see the amount of commotion and disruption that's happening in the world around us. We're Genpact. We're a company that is a professional services organization. We sell to Fortune 500 companies the notion of digital transformation, and we help them discover, plan, design, implement, and get it off the ground. And across those clients we serve and others we engage in, I will tell you the number one topic of discussion when I speak with their boards of the companies we serve is how do we get AI to get up and running in the enterprise? Where do we apply it? And how do we get to critical mass? And we've thought long and hard on this topic, and I want to take you through a couple of things we've learned that unlocks that potential for AI in the enterprise. We have two boys. Before they were teenagers, so in their preteen years, each of them bought some chips from eBay and other places and got a couple of motherboards and assembled their own computers. My wife and I are in a little bit of a denial, but one of them is a really good gamer, and the other one is a good streamer. These are career tracks that we don't necessarily endorse for them. But all the same, they were able to build high-capacity streaming computers or really high-performance gaming computers by assembling chips on motherboards, by mixing and matching different components of a Lego bricks of sorts. And yet, when most of us grew up, and certainly dating myself when I grew up, my first exposure to computers were DEC VAX boxes, and back in those days, there were two options. There was option one, and there was option two. You couldn't change the memory configuration. You couldn't put something else on the side. It's basically how they came in. And so the computing industry has evolved from being a large monolithic application, a full stack, to actually modularize componentry where you mix and match components. And that, if you will, has expanded the size, the scalability, and the applicability of computers in all our lives. This notion of modularity is important when we think about AI in the enterprise because it drives adoption at scale, and it's something we worry a lot about. But the other thing that modularity brings, and if you go back and think about this, is use cases that it can be cross-applied to. So I grew up with a passion for photography. When I was young, I used to take a lot of photographs, and obviously in my lifetime, perhaps in many of yours, photography changed from a science of chemistry, which is what it used to be, to a science of mathematics, which is what it is today with digital photography. And that was a change, that was an evolution, obviously brought significant benefits, and we were no longer dealing with chemicals and exposure and light and those sorts of things. But here's what it really did. It changed the form factor of that module. And now in this new form factor, I didn't have to wait for my photographs to be printed and put in that little hard copy bound album of photographs that we used to keep in our home when I was growing up, to now I can put it on my Instagram within 30 seconds. I can include it in my email update to someone, that my wife can send out a Christmas letter at the end of the year summarizing key events that have happened in the family. And the fact that the form factor changed in that modularization journey for photography is what has enabled this proliferation of use cases, this ability to apply it in many different areas. And so we think about the important question of how do we allow enterprises to take advantage, unleash the power that is available within AI that we're already sensing, feeling, and getting used to. I think it becomes important to solve for this problem of modularity and to bring it in a form factor that it becomes expansively usable. But how do you do that? Think about the last time you drove for 30 minutes. Perhaps it was your drive home last night. If you're like me, there's probably 8 turns you took. There were 7 different lights, the variety of cars and bicycles and trucks and other things that were on the road around, behind, and in front of you. If you're like me, you likely cannot remember which of those 8 lights were red or green or yellow when you went into the intersection. And you likely cannot remember what combination of cars and bicycles and vans and other types of vehicles were on the road yesterday or the last time you thought about it. And yet, every single intersection you navigated through just fine. You did it safely, and you did it correctly. So let's walk back and think about what happens in that mechanism in what is the most evolved sense of cognitive systems in the world, the human brain. In the flash of that snap of my fingers, there is 11 million inputs, I'm told, that has reached your brain. Scientists know this today, and we know this to be a fact. And yet, our brains cannot accept more than 20 to 40 inputs in that second. And so the way the human brain has evolved is it actually takes a lot of those inputs and it has these synaptic molecules. It has these cognitive subroutines. It has these little pieces, building blocks of logic. So when you go into the intersection, that routine comes into play, that molecule comes into existence. It handles the situation, then it kind of fades back, and you go on to the next thing. And so in the end, we find that the human mind actually has these molecules, these modules, these components of logic that are mixed and matched at the right place, at the right time, for the right decision. Let's continue that story for 1 second. This probably happened to you before it happens to me. I walk in my kitchen door, I pick the mail on the way in. I'm literally putting my mail down on the table as I'm calling out to the kids. And without even thinking about it, I've actually started sorting out the mail. I've put them into 3 piles, small piles. I know that the first one are a set of advertisements and real estate, open houses down the street and the like that will just go into trash within a second. I know that the second pile are a couple of the letters from people that I'm going to actually respond to because they're friends, their family, it's a card. And I know the third set of letters are actually bills that I'm going to pay. And before I've even thought about it, in my mind, I've made a note that at 7 a.m. on Saturday before I go for my tennis, I'm going to put aside 30 minutes to take care of all my bills. This happens routinely. We don't even think about it. So we took that idea and we said, what if we replicated this mindset in the enterprise application space? And what if we took this problem, the one that I just described, in the world of accounts payable, in enterprise finance and accounting? And what if we said enterprise accounts payable is a function that can be reduced to 4 problem sets? 1, extraction. So you need to look at a piece of paper and you need to tell it's an advertisement versus it's a table with content that I need to do something with. 2, classification, which is this is something I want to respond to, this is something I don't want to touch. 3, reasoning. This invoice is appropriate because it matches this document, this purchase order, and this shipping mechanism, and so we'll pay it or not. And 4, learning, which is to say over time, I've noticed this pattern recognition that every time I get an invoice from this one vendor, the sales tax is off because they think I'm in the wrong state, or the payment is going to be delayed because they have a track record of doing it. And so if you reduce that problem to those, and I'm putting this in machine learning terms, problems of extraction, classification, reasoning, and learning, then you find that we can actually contextualize the world of AI into modules, into Lego bricks, into components that can be quickly integrated into a value chain. Now, here's the trick. We've been in the artificial intelligence transformation business for years now. We have deployments from banks to insurance companies to consumer goods companies to industrial manufacturing. We work across the space. And the thing we've learned is that AI, when you approach it as a monolithic large application, is very difficult to get off the ground. But if you deconstruct that, you think about what is a module, in the end, a module has 3 components to it. You need a strong AI engine. And the good news is they're broadly available. They're increasingly a commodity, and they're available as you need it, as a service, turn on and turn off. And so that's the best part of the story. But to get to an application that isn't going to perform at a 40% level of accuracy, you need to be able to train that horizontal engine with labeled data. Now, data brings its own set of issues. We talked about ethics and bias earlier. And so the notion of a platform that allows you to think through synthetic data and derivative data and clean original data and be able to manage that in a meaningful way with the entire hierarchy is a large part of getting this right. And we talked about ethics and bias that comes from drift in data, and then making sure we think comprehensively about it becomes really important. And so data becomes the second leg of the stool. The third leg of the stool is actually labels, and labels are fundamentally coming from domain knowledge, from understanding of the context, from figuring out that this is about a car damage and in the insurance industry, and it needs to be traded in this way versus that way, that it needs to integrate into processes, one upstream and one downstream, and it needs to be able to fit into that in the following fashion. And when you get all 3 of those right, in other words, when you have the right AI engine as a horizontal platform, and you treat it with enough data that is broad and wide and right and correct, and then you label them with the right level of domain knowledge, you build these pre-trained accelerators. They are those small bits of cognitive decision-making components. They're the Lego blocks. They're the chips that'll go on the motherboard that my kids would use to build their computers. And we realized that as we do this, the reality is AI applications, for the most part, I can get a client up and running at about 80 to 85% today in a mission-critical, lights-off operation in the real enterprise. But you don't get to 100% on day one. And so what we really needed to do is to put a managed services around an AI application. It's a combination of AI capability and human capability that actually takes care of those exceptions, the stuff that falls out, the stuff that isn't in that 84% number today. And what's been important is as we take care of those exceptions, that we capture the logic behind them and we feed them back in a reinforcement loop into the AI engine. So it goes from 84 to 86 to 88 to 90 to 92%. And that's the trajectory we've seen. And so we're big believers in this mindset. We've built about 60 of these pre-trained AI accelerators. We've got them up and running in lots of different environments. I'll give you a few examples in a minute. And we find that it's been one of the keys for us working with our clients to unlocking artificial intelligence in the enterprise. Let's walk through a few examples. By the way, before I did the examples, I just want to point out that one of the learnings, even before we got to AI, was the fact that for most clients, all of this is a journey. It's not a destination. In other words, there's not a one-stop endpoint. There are many stops on the way. And the ability to hold that entire journey together, to be able to integrate the different components, to be able to get to a larger whole, and to preserve the investments that have previously been made in the steps to get there, you actually do need a digital business platform. Ours is called CoreUp. There's a few in the industry. And the idea of the digital business platform is to provide governance in this digital-first, AI-first world, to provide the integration of these different modules so you can mix and match as you need to, and the orchestration across these services that each of the components offer into a composite whole. And we have built our pre-trained accelerators on top of that CoreUp business platform. It can be done other ways as well. So here's a few ways we've used it. We're using it today already. I hosted the managing director of Envision Virgin Racing. It's a Formula E racing team earlier this morning on LinkedIn Live. We had a great conversation because they're using our capabilities fundamentally to do four things. They look at all the telemetry that's coming off these race cars as they're racing, and and use that to be able to derive conclusions. I'll come to that in a second. We look at satellite data on the traffic patterns and the weather and the location and the dust on the road and the friction on the tarmac on the road that the cars will be exposed to. We look at competitor information, which is how are the other drivers racing and what is expected of them on this turn, when you're slow, when you're fast. And then we look at audience information to see how the fans actually follow that. And bringing that ecosystem of connected participants, putting together a foundation of data upon which we can drive these insights. We're applying AI accelerators to fundamentally make recommendations on how many laps are remaining in a race. An e-race is a little different from a normal race. It's not a distance race, it's a time race. And so what you have to do is you have to be able to predict how many laps are remaining at any stage in the game, because these electric cars, you have a fixed amount of battery, and you don't want to obviously run out of battery before you end the race, but equally, you don't want to end with 40% of your battery still remaining because you could have pushed harder. And AI accelerators is allowing us to, in this case, in a real-life example, estimate the number of laps remaining 15 laps before we would have otherwise been able to do so. So we're getting meaningful results from this. In the insurance industry, and now increasingly in the leasing space, we're finding that our ability to use deep neural nets to be able to train them and apply AI accelerators that can look at images of damaged cars and be able to estimate the cost of repair is allowing us to fundamentally transform how the space operates and the competitive advantages a provider can bring to its clients. And we use AI accelerators to make this happen. In consumer goods and in the retail space, one of the largest challenges is the dilution at the top line level from trade pays. These are promotions that are done that are often very difficult to reconcile, and they bleed right off the balance sheet, right off the income statement, right from the top. And it's a big challenge for large corporations to be able to manage. And now we're able to extract information from previously dark data, invoices and contracts and statements and those sorts of things, reconcile them with other sets of documents, invoices, purchase orders, legal contracts, and then be able to bring out the deltas that can be put together to say what is the right dispute and what is wrong, and be able to claim or reclaim the ones that are incorrect. And that's driving, for some of our customers, millions of dollars to their income statements in the back of that. And that's AI accelerator in use to get that up and running. The next time you're at a pharmacy waiting for a prescription, the reality is you should take a minute and think what's going on behind the scenes. Why is it taking the time for that to be taken off? Why can't you just go and grab it off the shelf? What's the delay? And here's what's really happening. The doctor, when she writes the prescription for you, writes it in a different format than the one that's going to get printed and put on that bottle or that medicine packet that you're going to eventually receive. And there's a process associated with taking that original information and translating it into the consumer labeling that is going to come off. And that'll differ based on a variety of different things. We're applying accelerators, pre-trained AI accelerators, to solve for this problem of actually converting that medical instruction into the instruction you'll get in the label of the medicine you get. And that's, again, a great use of looking at taking a horizontal piece of AI technology, but training on medical catalogs, training it in the language that is going to be used, and then doing that with domain understanding to be able to get to the high levels of accuracy. And then finally, I'll give you one last example, and it comes from the world of banking. We serve many large banks across the globe. And one of the many things we do for them is we help them understand risk in their portfolios. If you have a lending portfolio, if you're a large bank, you'll likely be in a scenario where you have 5,000 balance sheets, 5,000 companies in a portfolio. 5,000 companies, each of them will have their own balance sheets, their own financial statements. And hidden and embedded in each financial statement will be an understanding of what the risk is. Traditionally, the way the industry worked and works in some part is that there's a set of financial accountants, CPAs and the like, that'll go through those balance sheets, that'll understand the risk, that'll compile it across the portfolio, and then be able to come back and report on what that overall risk is. And of course, this is what's required to manage risk and volatility in the banking industry. Except it takes a lot of time, a lot of effort. It's open to human sort of interpretation quality gaps. And as a result, it's not as responsive to current events, which obviously we all know from what's been going on in the world in the last 10, 20 years is a really important dimension of managing risk. And so today we're using pre-trained AI accelerators, and what we do with them is we'll take the same balance sheet, we'll take that same portfolio of 5,000 different companies, each with a balance sheet and a couple of accounting statements. And in seconds, we'll ingest that information, we'll extract the components, we'll apply risk scores, we'll aggregate it across different companies. These companies will have statements in 3 different languages. They'll have 2 accounting standards that could have been applied to that, and accelerators will work through the understanding of GAAP versus another accounting standard, on reading a balance sheet in Spanish versus reading it in English. Then we will extract all of that and compile one single risk score for the entire portfolio. And as it does that, because we use AI accelerators, we're also able to solve for the problem of explainability. Because the issue obviously becomes, I'll give you a score, and you look at the score, and you'll say, well, why that score? Well, why not something else? Well, explain it to me. And traditionally, if you design AI as one monolithic large engine, the answer is, trust me. It's obviously better at doing it. We've proven it before. You see what happened over there, and thus this is right. But when you break that application into modules, my answer to you when you ask me that question will be very simple. Say, click on it. And you'll click, and it'll drill to the next level down into the numbers for each of the companies in that portfolio. And you'll look at the 10th one and say, well, that doesn't look right. And say, great, click on it. And you click on it and break down the actual numbers that came off the balance sheet. And you look at something and say, well, that's the reason that number is high or low. And say, well, click and drill on it. And you click and drill. And eventually, it gets you to the 2 sentences that came from page 19 on the balance sheet of that company that was ingested, read, and interpreted one way. And the reality is, you could look at me and say, well, Sanjay, I mean, that's nice, but now it's 2 sentences. What's the logic behind that? And I'd say that's exactly the logic you would have used before. So the fact that you're able to disaggregate this logic tree, that you're able to provide the breadcrumbs, that you were able to break into the modules that allow you to get it down to the right level of depth, is a significant driver of explainability in the enterprise. And really, at the end of this, the usage and the applicability of artificial intelligence in the enterprise. So if you don't take anything else away from my discussion today, here's what I would leave you with. The world's going to go through a significant amount of change, and artificial intelligence will become to be, at least for the enterprises, a mainstream capability. I know this from the boards I speak with today. We know this with the level of investment that our clients and companies around them are making. And we know this with the interest that you are showing in the space. But to be able to harness that potential and to harvest in the notion of an enterprise, it's going to be important to break it down into the chips of the computer of that future, into the Lego blocks that will come together. And we believe pre-trained AI accelerators will become the way that'll come to be, because pre-training will take you from 40, 50, 60% generic accuracy to 80, 85, 90% specific accuracy. And then this human-in-the-loop managed services platform next to it will allow you to take the learnings from the remaining 10% and continue to improve that. So the next time you're taking a photograph, you're standing at the pharmacy, you're looking out to space, you're thinking about the future of AI in the enterprise, just remember that modularization, and in some ways the pre-trained AI accelerators, will be one of the keys that unlocks the power for artificial intelligence in business applications. I'm going to be around a little later today. We're at the end of our time now. We have a booth right outside this area, and happy to take any questions at that time. Thank you.
Thank you very much. So, and one question I had, how did you get 13,000+ followers on LinkedIn? Yeah. I think that's the real talent.
It's the topic, not the person.
You're too modest.